Hello comrades, so today we are starting with a new series known as Oscilloscopes 101. In this, we'll get to know everything about them from the intro to the basics and advanced stuff as well. Today's topic, there will be the basic introduction, the comparison with its friend, its multimeter, and some basic controls like the interface and all. So let's get started. So the first question comes to mind is, what is an oscilloscope? Basically, it's a device which can plot multiple electrical quantities such as voltage, current over time, and you can observe how they are changing. So basically, you get this weakly waveform which is known as a square wave, but you only know it's a square wave. You cannot see it on a multimeter. So multimeter does what? It does only track voltage and current, but it does so in real time. It cannot do that over a time period. That's what exactly a DSO does. And DSO stands for Digital Storage Oscilloscope. So we'll move our camera there to get to know about that. So this is what a DSO looks like. It's a fairly big device, so you get around this thing. And yeah, this is what I was talking about. This is a square wave, but we'll get to that at a later point. So for now, we'll get to know about this. So this is the display of it, where we can see the waveforms, time and stuff, everything. So, and this is the control panel. Now it might look a bit daunting at first, but trust me, it's so simple to use. Now first getting to the basics, here we have the vertical and channel selection menu. So as the button suggests, if we click on, there are two channels basically, channel 1, channel 2. This is known as 2-channel oscilloscope, and there's this parameters mentioned here. It is 100 megahertz and 1 gigasamples per second. So this thing can measure bandwidth up to 100 megahertz, and the thing is it can measure above that, but the peak signal waveform and quality and everything accuracy will get dropped as you increase the frequency further. So, and this thing, 1 GSA per second means 1 gigasamples per second. So basically it means that it can point 1000 samples, 1 giga samples in a second. So sample is basically a point in time. So if this is our 1 second, then 1, 2, 3, 4, 5, 6 and all this will be 1000 gigasamples per second. So that is how it plots time waveform. So these are its two channels. These connectors are known as B and C connectors. So there's a grounding outlet here, and inside this the main signal goes through. And we cannot just connect any wire and check the waveform here. It doesn't work like that. With this we have to use what we call as probes. So a probe looks like this. We have a switch here, we have a clamp like this, so we can like clamp a wire or something like this. It can grab onto it. And there's one also thing here which is known as the ground cable. Otherwise, if we connect this only and not the ground, then this will just jitter and show noise. So that's a later thing. First we'll get to know about the channels and stuff. So it says channel 1, channel 2, external trigger and gen out. So this is a generator as well. That's why these two values are there. So this also has a function waveform generator. So it can generate up to 25 megahertz of signal with accuracy of 200 megasamples per second. So that much points of resolution it can give out on the signal generator. So that's a different topic. We'll get back to that on a future video. For now, this is the volts per div knob. Now you will ask, what is volts per division? So basically, if you see, there is a grid here. These are the midlines, the x and y axis. So on the y axis we have our time. On the x axis we have our voltage changing. So it defaults to be at position 0. So right now we don't have any channels enabled, so we are not seeing any waveform. So we'll just enable channel 1. Now we have got the line. So right now at this point there is no voltage, but if I touch, I cannot touch here, but if I connect the probe, then this will start to rise. Yeah, so this is the probe connected, and right now if I touch it, there's some noise, if you can see. So it basically captures noise for when not connected anywhere. And now the volts per division thing. So basically what this knob does is it changes the waveform scale. So right now it is at 10 volts per division. So one division is 1 square. So 10, 20, 30 and 40. So total of 40 volts. Right now the channel setting, if we change the knob, the volts per division value changes. So it's now 20 volts, 50 and 100, and now it's at 2 volts, 1 volt. So basically each square means 500. Now for this range it means 1 square equals 500 millivolts. This range is set by this knob. Similarly for the time period we have the seconds per division knob. So in this whole frame we have these boxes as well, 1 2 3 4 5 6 7 8, from this midline up to 8 here, 8 here, to total of 60. So what each box time refers, this is shown here. So it's 200 microseconds per division now. So this, from this 200, 400, 600, 800, 1000, 1200, 1400, and this is the time. We can change this time by changing this knob. So now right now it's at 150, and we can increase it and change it as well. So as we increase the time period, the signal sampling rate decreases or increases. Like if we go too deep into the signal, like for example we'll getting around 10 microsecond, so the sampling rate gets bigger and bigger. And right now the its max sampling rate is 1 gigasamples per second. So if we set the default settings, like we'll do an auto set here. So basically this thing automatically acquires a waveform and sets it accordingly. So right now this thing is a demo signal. It's 5 volts at 1 kilohertz square wave. So we'll connect a probe to here, and right now you can see there is nothing. The trigger point is up. So basically our oscilloscope is not properly set to display this waveform. So one thing we can do is manually adjust everything, like the volts per division and all. You can change, see the waveform value changing. But if we want to go the easy route, we will go auto set. So what this thing does is it automatically changes the settings. So we get a proper square wave here. So yeah, and let me show the knobs in action. So this is the time per division. If you change it, it changes the waveform shown. So you can literally see how the waveform is changing from this into time. Let me turn off. So in this time period, it's per division means 500 nanoseconds. So it's at 500 megasamples per second. And if we go to the absolute maximum, it's 1 gigasamples per second. So we can change see the absolute minimum noise which is generated even by this DSO. And if we zoom out, basically these are zoom in, zoom outs, but electrically. So if we reduce the time, then the signal gets like unusable to show. Like we cannot derive any useful information from this. This was the time per division, and let's now get to the voltage per division. So if we increase this, we see the waveform scaling is affected. So changing this clockwise means we increase the scaling, anti-clockwise means we decrease the scaling. Yeah, so that was it for today. These are the basic things. Tomorrow we'll get to look at much more things. So it would be a trigger level. In the next video we'll get to know about trigger, measure, acquire, cursor and all the advanced things in later videos. So for now this was it. Hope you learned something new, and I'll get back to you soon. See ya. Bye bye.